Okay, grade 10s. Our lesson is on um, definitions of trig ratios. So basically, we're looking at a new topic now in grade 10, trigonometry. But the good thing is it stems from, or our basis will be on things that we are familiar with, concepts that we are familiar with. On page 102, if you can go to page 102, you need to be familiar with the following concepts. That is your similar triangles. Remember, when you talk of similar triangles, similarity, when I give you two triangles and I say prove that these two triangles are similar, what we then needed to do was to prove that the angles are equiangular. So you're looking at the two triangles. This angle on this triangle is equal to this one, and you must give me a reason why. The second one corresponding to the second one in the second triangle, and then the third one, remember I told you don't need to worry about it, because once the two are equal, then the third one automatically becomes equal. So once you can prove two pairs, then the third pair is automatic. So your similar triangles, the theorem of Pythagoras. What does the theorem of Pythagoras say? In any right angled triangle. So with the theorem of Pythagoras, the triangle has to be a right angled triangle. Very important. Once a triangle is not right angled, then the theorem of Pythagoras does not apply. In any right angled triangle, and I'm going to use in exercise 5.1, if I can use triangle ABC as an example, that's a right angled triangle. What we need to be very careful of, let me draw that triangle. Remember, our right angled triangles, we must be able to deal with them. It doesn't matter where they are facing. So here I'm giving you a right angled triangle that is in this way. All right, and then we're given the 90-degree angle. Remember, the Pythagoras theorem, I emphasized it has to be a right angled triangle. So there is our 90-degree symbol there, the right angle. Or in some cases, it can be indicated on the information. That is enough to say the triangle is right angled. So in any right angled triangle, what do we need to have? We need to know these sides. I'm looking at side AC. Side AC is the longest side of my triangle, and we call it the hypotenuse. All right, so that's my hypotenuse there. All right, then now I'm going to look at what I'm given. Also, I'm given angle theta there. So now angle theta, when I'm looking at angle theta, I want to name the other two sides, which is side AB and side BC. The naming of AB and BC depends on my reference angle. What am I saying? If my reference angle is theta, then BC is the opposite. Do we agree? Then if my reference angle is theta, then AB is the adjacent. All right. But now if I get another angle there at the top and I name it angle beta, all right. Now I want to name, remember AC, the hypotenuse doesn't change. It's the longest side, is the side opposite the right angle. So that one doesn't change. All right. So now I want to name side AB and side BC in relation to angle beta. Now, in relation to angle beta, AB is now the opposite. Do you see? So it's now different. With reference to angle theta, BC is the opposite. In relation to beta, AB is the opposite. In relation to beta, BC is the adjacent. So once we can know that, then we are good to go. All right. Then the other thing, remember initially in our question, beta was not given. All right. If I may want to write the value of beta, mathematically, size of beta in terms of, the question will come in terms of theta. All right. Then what you're going to do now, we're going to use a concept that we know. That is the sum of angles in a triangle, which is 180. So if I'm calculating the value of beta, and we're saying do it in terms of theta, let me redraw that without beta so that it doesn't confuse you. A, B, C. I've got my angle theta there, my 90-degree symbol there. Now I want the value of angle C, let's call it that, in terms of theta. All right, now it's going to be, we know the sum of angles in a triangle, it's 180 minus these two. Now I'm putting a bracket. Do you see that? Very important, because this is theta, this is actually 90 plus theta. It's an expression, hence I'm putting it in brackets, very important. And then if I simplify, opening my brackets, let's open our brackets there, it will give me 180 minus 90 minus theta. Agreed. Like terms, these are our constants. 180 minus 90 will give me 90 minus theta. So the size of angle C in terms of theta is 90 minus theta. That we must be able to do. So it's not always that our angles are given in numerical values. We can have our angles in terms of theta, in terms of beta, as an expression. Do we see all that? All right. So that was just a demonstration there. Okay, so that was your theorem of Pythagoras. Let's go back to our theorem of Pythagoras. That's your hypotenuse. Then we need to concentrate on our reference angle. Let me redraw my triangle now and go back to my Pythagoras theorem. That's my A, that's my B, that's my C. We're given angle theta initially and my 90 degrees there. All right, so now if one other thing I want you to use, because when we're doing our before I go on to that, the theorem of Pythagoras states that in any right angle triangle, the square on the hypotenuse is AC. The square on the hypotenuse is AC. The square on the hypotenuse is equal to the sum of the square of the two other sides. So I'm going to square the two other sides. That's my AB squared plus BC squared is equals to the sum of the square of the other two sides. And usually we need to acknowledge the use of the theorem, Pythagoras theorem, in brackets there, whenever you write your theorem. So you write your theorem, then you can substitute in a situation where you must calculate a missing side. All right, so this is just a recap of what we know. So with that demonstration being said, I'm going to ask you to do number 1, number 2, we're on page 102, right? Exercise 5.1. Number 1, number 2, number 3, and number 4. I've spoken about all the concepts there. They're not new, it's just a recap. This was based on concepts that you must be familiar with. Right, now on page 103, it comes to how we name our triangles. If we can go through that, then we'll be able to now get to our new concept. Welcome. All right, definition of trig ratios. Definition of trigonometric ratios. Okay, I'm going to draw a triangle because that's what I'm going to use. Okay, let me use the first triangle, which is again triangle ABC. Triangle A, B, C, and theta there. All right. What I want us to use, because when we're looking at our trig ratios, we've got 3 trig ratios with the sine of an angle. We have the cosine of an angle. We have the tangent of an angle. All right. But in our everyday use, we're going to use sine. So that will be, in this case, I'm going to use the angle that I'm given, sine theta. Cosine, we use it as cos theta. Tangent, we use it as tan theta. So these are our trig ratios. So whenever I say which trig ratio are you going to use, you must know sine, cos, tan. So now we need to define these trig ratios in any given right angle triangle. These trig ratios, again, just like the Pythagoras theorem, they work in a right angled triangle. Are we together? All right, so the next thing I want us to take note of, and this is how I keep my trig ratios. There's this word, so ka to wa. So ka to wa. Sine, cos, tan. So this gives me my definition. So sine, which is my sine theta, let's use our reference angle there. Sine theta is defined by O. Remember, when we're looking at our triangle, we defined the hypotenuse, we defined the opposite, we defined the adjacent. So those are what we're going to be using. So sine is given by opposite over hypotenuse. Cos theta is given by, let's finish that off, adjacent over hypotenuse. Tan theta is given by opposite over adjacent. All right. So katoa will take you a long way, because then you'll remember. All right. Now let's go back to our triangle and now define these ratios in a given triangle. All right. So now when I look at my triangle, let's start with sine theta. Sine theta is equals to, so I'm going to write opposite over hypotenuse. What is opposite? Okay, let me fill in my triangle from the textbook on page 104. That is AB is 4, BC is 3, and AC is 5, because now we want to write the numerical values of our ratios. Okay, so sine theta is given by opposite over hypotenuse. And then opposite over hypotenuse, let's first write it in terms of the labels of the triangle. What is the opposite? What is the opposite? It's BC over, what is the hypotenuse? AC. What is the value of BC? It's 3. What is the value of AC? It's 5. That's it. So that's what our lesson is about today. Very easy. It's doable. All right, let's go to cos theta. Cos theta. All right. Cos theta, we go to SOHCAHTOA. Cos is adjacent. Adjacent over hypotenuse. All right. What is the adjacent? Let's go theta. Theta, there's theta. Which one is the adjacent side? It's AB. Over what's the hypotenuse? AC. What is the value of AB? 4. What is the value of AC? 5. Perfect. Tan theta. Tan theta. Tan theta. So katoa will help us there. Tan is given by opposite over adjacent. What is the opposite? Theta opposite is 3. Oh, sorry. Opposite is BC. We need that first. BC over adjacent, which is AB. All right. Then BC is 3. Am I right? Yes. Over AB, which is 4. So that's how we do it. All right. Now I want to give a twist to this before I give you work to do. Let me add on my triangle there and or let me actually redraw. Let's redraw this triangle again. But I'm going to change. So it's still A, B, C, 90 degrees, 5, 4, or 3. Then now I'm changing my angle. I'm working with angle beta. Alright, we must be able to do sine beta. Okay, what is sine? So katoa, so let's bring so katoa down. So katoa, opposite, my space now. That is opposite over hypotenuse. So which one is the opposite in relation to beta? The opposite has changed now. The opposite is now AB. Agreed? AB over hypotenuse it's AC, doesn't change there. So the answer will be 4 over 5. If I want to do cos beta, cos is given by adjacent over hypotenuse. All right, adjacent. What is the adjacent in relation to beta? Adjacent is BC over the hypotenuse. Hypotenuse is AC. Hypotenuse doesn't change. What's the value of BC? It's 3 over hypotenuse 5. Let's do tan beta. Tan, so katoa tan is opposite over adjacent. Oh, can you see there? Let me just bring that up. Is equals to opposite in relation to beta is AB over adjacent is BC. So the answer will be 4 over 3. That's our definitions of trig ratios. If you did not understand, just go back to the beginning, because the most important is when you are given your right angle triangle, you check which one is my reference angle. Then in your reference angle, you must know which one is the opposite in relation to that angle, which one is the adjacent in relation to that angle, because the opposite and the adjacent change depending on the reference angle. The hypotenuse was set, it doesn't change. It's the side opposite the 90-degree angle. So once you can define your opposite and your adjacent, and you've got your SOHCAHTOA, then you can do any definition. That being said, on page 104, I want you to just look at the 3 triangles that are given, and they've actually worked out all the ratios. It will make sense to you after you have gone through the lesson. And then if you can, then go to page 106. That's your homework now. Of course, you can look at all the questions that are there in as practice. It doesn't really take time, but I want you to do number 2. Oh, let me bring it down. Number 2, it's a right angle triangle. Now it's facing downwards. Remember, it doesn't matter where your triangle is facing. You must be in a position to define. All right, so that's angle D. So if they say sine D, then you must know this is my opposite, this is my adjacent. Hypotenuse doesn't change. This is angle F, this is angle F, this is my opposite, and this is my adjacent. Hypotenuse doesn't change. If you can do that, you're good to go. You'll do number 2, it's A to F, and then you do number 6 on page 107. I'm trying to bring that one on the screen. Number 6, now it's a combination of 2 triangles in one, but that mustn't be a challenge. So you're going to do number 2 and number 6. Then we will continue when we look at calculations in trigonometry as our next lesson. Thank you.